Here we'll be talking about the difference between permutations and combinations. Now, a permutation, you can see it says here, is a set of objects in which order is important. Combinations, on the other hand, is a set of objects in which order is not important. So, for example, suppose you had a club and you wanted to choose a president, a vice president, and a treasurer. If I chose Mike as president, Gabby as vice president, and Jordan as treasurer, that would be different than choosing Gabby as president, Jordan as vice president, and Mike as treasurer. So the order that you say their names matters. A trick I use to remember it, I think of permutation and position. The position that you place the people or objects in matters. So permutation, position, they both start with a P. Okay, now if we look at combinations, order doesn't matter. So if you had a club and you just wanted to choose 3 people to represent the club, if you chose Gabby, Jordan, and Mike, that would be the same thing as choosing Mike, Gabby, and Jordan. The order that you say their name in does not matter. Okay, so let's take a look at an example with each of these. We'll start with a permutation. Let's suppose we have 10 people in our club and we want to choose the president, vice president, and treasurer. Well, what we're really doing is we're picking a position for president, a position for vice president, and a position for treasurer. Now, if you think about it, if there's 10 people in the club, we have 10 people to choose from. So we have 10 people to choose from for president. Once one of them fills that spot, we have 9 people to choose from for vice president. And then once that person fills that spot as well, we have 8 people left to choose from for a treasurer. And when you can say the word and, what it's telling you to do is you want to multiply. We want to choose a president and a vice president and a treasurer. So you would just multiply these together and you would get 720. Now, another way of writing 10 times 9 times 8 is 10p3. From the 10 people, we want to pick 3 of them to fill our position. So 10p3. It means just start at this number, and you're going to multiply down by 1 each time for this amount of numbers. So we're going to start at 10, and then we multiply a 9, and then an 8. So we have 3 numbers here. Okay, with a combination, let's give the same problem. Let's say we have 10 people in our club, and we want to choose 3 to represent our club. Well, instead of writing 10p3, we would write that as 10c3. And what 10c3 means is it means you want to take 10p3, but because there's going to be repetitions, because, like we said before, Mike, Gabby, and Jordan is the same group as Jordan, Gabby, and Mike. What we have to do is we have to divide by the repetitions. So what we're going to divide by is the number of people we're choosing factorial. Now, what a factorial means is you want to take that number and you want to multiply down by 1 less each time until you reach the number 1. So it means 3 times 2 times 1. So, for example, 5 factorial would mean 5 times 4 times 3 times 2 times 1. Okay, now we already said that 10p3 means 10 times 9 times 8. Okay, so that basically gives you 720 divided by 6, which is 120. So 10c3 is going to be a lot smaller than 10p3 because when order matters, you can come up with a lot more groups than when order doesn't matter. Okay, so now what's nice is you can use your calculator to do these calculations. So let's take a look at the 2 examples we just did, 10p3 and 10c3. All right, so if we start with 10p3, in your calculator, first thing you're going to do is you're going to plug in the number 10. And then to get the p, you're going to hit the math button in your calculator, and you're going to scroll over along the top until you see PRB, probability. Then you can scroll down to choice 2, which says NPR. And when you hit enter on that, we can now plug in this 3 that comes after the P. So now when you hit enter, here's what your calculator gives you. That's 720. Okay, so now let's try the same thing with 10c3. So you could first type this 10 into your calculator. Then you could hit the math button, and scroll over along the top until PRB is highlighted. This time you're going to go down to number 3. So you could see the C right there, NCR. So now you could hit enter and plug in this 3 that comes after the C. And you'll see in your calculator it says 10 NCR3 is equal to 120. Okay, so let's try out some of the examples from your packet. Number 1, it says there are 12 boys on a baseball team. In how many different ways can the coach choose a starting team of 9 players from the 12 boys? All right, well, first thing we have to decide is if we're using permutations or combinations. Well, since he's just choosing a starting team, it doesn't matter what order we put the players in. We're not putting them in positions. We're just choosing a starting team. So for that, we're going to use combinations. So from the 12 boys, we're going to choose a group of 9 to put out on the baseball field. So again, if you want to do that in your calculator, you would first plug in this number 12 right here. You would hit the math button and scroll over to PRB. We're going to scroll down to choice 3 right here with the C. And when you hit enter, you can plug in the number 9. And hit enter again, and you can see right here the calculator gives you 220. Okay, letter B says, in how many ways can the coach create a batting order with 9 players from the 12 boys? So this time the order we position them in matters. So when order matters, we're using P. So from the 12 boys, we want to pick an order for 9 of them. So we're going to do 12P9. All right, so it's basically the same thing in your calculator. You're first going to plug in the 12. You're going to hit math, go over to PRB, this time down to choice 2, hit enter, and then let's plug in this 9. And when we hit enter again, you can see the number we get on our calculator is a lot bigger. Looks like we get 79,833,000, and don't forget your commas, 600. So when you're putting them in an order, you can see the answer is going to be a lot bigger than when you're not creating an order, when you're just creating a group. Okay, so let's take a look at the next 3 problems on this page. Okay, number 2 says 8 people are entered in a race. If there are no ties, in how many ways can the first 3 places come out? All right, so here order matters because we want a first place, second place, and third place. So we're going to be using permutations. Now, since there's 8 people in the race, from the 8 people, we want to pick an order for 3 of them. So it's going to be 8P3. If you follow the same procedure that we did for number 1 in your calculator, you will wind up with 336. Okay, number 3. How many different 3-member teams can be selected from a group of 7 students? So we're just choosing a team. We're not giving them any order or titles or positions. So here we're going to be using combinations. So we have a total of 7 students we're choosing from, and we want to choose 3 of them. So we could write that as 7C3. And you can do that in the calculator, and when you do, you will wind up with 35. Okay, and then finally number 4. A basketball squad has 10 players. Which expression represents the number of 5-player teams that can be made if John, the team captain, must be on every team? Okay, well, if John, the team captain, must be on every team, that means there's really only 9 players to choose from. So 9 to choose from. Okay, now, again, since John is always going to be on the team, he's going to be out there on the court with them, we really only have 4 positions to fill. Okay, so from the 9 people to choose from, we have 4 positions to fill. So we're just choosing a group. There's no order. We're not giving them positions. So we're going to be using C. So from the 9, we want to choose 4. So choice 2.